Jiha from Group 12. Under my right is...
I'm Muhammad Fitri bin Mazlan.
And I'm Muhammad Khairul Anwar.
We are going to present about analysis on forklift for finite element method. Before I proceed, let's first look at the outline. First, there will be objective, then scope of study, technical parameters, methodology, FeMap Nastran, which is the most important part of this presentation, results, and conclusion. The objective of this analysis is to basically study the stress distribution and performance of light forklift using the finite element method. Then we want to implement the use of technical software. The one we use today is the FeMap Nastran to analyze the stress distribution, and then we will compare the accuracy of analytical results when different number of mesh is applied. Lastly, to identify the optimum number of mesh implemented on subject of study. And from we are now is the forklift.
Hi, my name is Muhammad Khairul Anwar, and today I'm going to explain a little bit about the scope of study. In our project, we will study the fork, the front part, which is used by the forklift, and then we will study the maximum load that has been applied to the forklift, about 10,000 pounds. And then we have the boundary condition applied at the fork, and the back, which is the book support. And then we will gain the data from the finite method CST. And lastly, we will do the simulation by using the FeMap Nastran. And then for the technical parameters, we will take this part because we will need this part to study and to analyze. And then the part state are usually where load are applied and distribution load can be observed. The forklift is first draw by using the CAD, or we use SolidWorks, and then we transfer to the FeMap Nastran. And then for the methodology, this is our part dimension. This is our dimension. We use this part as a standard specification from the market. And then you can see the dimensions there, and this one will be the boundary condition that we apply, and you can get more information about this from my friend at the FeMap Nastran.
Hi, it's me again, Nurul. Before we start doing the meshing, we must first identify or set up the material for our subject. Since this is only a student version of FeMap Nastran, we have a limitation on setting the real exact material for our forklift. So we end up using the AISI 2025 carbon steel. Then we set up the stress distribution around 1 kN on the fork carrier.
Hi everyone, my name is Muhammad Fitri, and I will continue what my friend said just now. So after we set the material, for the next step, we have to set the boundary condition, which means the constraint for this problem. So basically, we just analyze on the front part of the forks. So for the boundary condition, we just set for pinhole at the back of the front part of the fork carriage. So basically, the 4 pin will be the fix for the constraints. So it doesn't matter if we put as a fixed constraint or pin constraint, because if we set it to the pin constraint, it still be the fixed constraint. So after we set the constraint, we move to the meshing process. So basically, in this project, we want to analyze which number of element is the optimum to get the most accuracy data. So for our project, we use number of element, the size of element from 0.45 to 3. Okay, after we set the mesh process, we move to the analyzing process. So basically, after we have set the mesh, we can run the FeMap Nastran. So it will produce some data, and then for this project, we just focus on the highest stress distribution. So in this example, I just show one type of size of element, and this is the result. And then after we get the result, we tabulate it, and then we repeat again with different size of element. So this is our data that we get with the size of mesh 3. We get the number of element 4670, and then the maximum stress is 22,613 psi. So basically we just change the size of element so that we can get the variety number of element. So from the data we can analyze which number of element is optimum to get the accuracy data. Okay, from the data tabulate just now, we can plot the graph here. So basically, we plot the graph maximum stress against number of element. Let's continue. After we get the data, then we have to plot the data to analyze the data. So basically, what we get here in this area, which means the smallest number of element, we get some fluctuation here in this region. After that, the fluctuation becomes smaller and smaller until it reach. We can say that it reach stable, steady state line. So basically, from this graph, we can infer what can we infer from this graph is when the number of element smaller, the data is not accurate and not steady. After that, after some point, the data is become steady state line. So from this graph, we can say that 300,000 is the optimum number of element for us to get the accurate data.
For the conclusion, we have learned how to analyze the stress distribution and performance of the light forklift by using the FINITE method, and we also successfully implement to use the mechanical software such as the FeMap Nastran as a medium to analyze the stress distribution. And in addition, based on the result, we finally identify the specific area where is the specific area that experience the maximum stress. And we also identify that the stress varies on the forklift based on the contour. We also, by using the mesh conversion, we know how small element that we need to ensure that the data of the finite element analysis are not affected by the changing of the size of the mesh. And due to the studio version, we have certain number of limitations when doing the analysis. For example, we cannot analyze the small size of we cannot analyze the small size of element, and we can analyze from 0.45 up until 3.0.